So the next algorithm that we gonna work on is support vector machine. So support vector machine is also one of the classification algorithms. So if your data is of classification kind, you can apply any of the classification algorithm which is dealt in the class. You can put decision tree classification, you can put random forest classification, you can put any sort of classification to that data. But based on the AUC ROC curve and based on the accuracy, you will say which model is very best for the particular data set. So likewise for in the classification, we also have this SVM algorithm. So let's see what is that SVM algorithm is. Support vector machine is also one of the supervised machine learning algorithm which can be used for both classification and it also be used for regression sometimes. All right. And however, it mostly used in classification problems only. All right. So in this SVM, actually we plot each data item as a point and n dimensional space where n can be considered as the number of features you have, with the value of each feature being the value of a particular coordinate. And then we perform classification by finding the hyperplane that differentiate the two classes very well. So in this support vector, what we do is we will be creating a hyperplane between two classes in order to classify the data, whether he has disease or not, whether he will quit the bank or not. Everything will be considered by the hyperplane. So let's see what is this hyperplane and all in few minutes. Okay, so first let's look into the data set. So let's suppose I have two variables, two input variables, which is x1 and x2. So let's suppose I have color as well as shape. Color as well as shape. Based on that, I would like to categorize them into fruits or vegetables. So here, let's suppose I've taken apple as well as oranges. So apples are red in color and oranges are orange in color, but both the sizes round itself. All right. So let's suppose these are the two classes that I have taken. Okay. Now what I do, I plot them. So all these red points are apples, all these green points are oranges. Okay, so whenever you point the features, so it will have different kinds of things like shape, in the sense like the centimeters or something else, not only round. You can consider what is the centimeter of its diameter or anything. So like that I have plotted the graph, and all the red points are considered as apples and all the green points are considered as oranges, like green orange, I mean oranges. Okay, now is there any possible way to separate these two classes? Is there any possible way to separate these two classes? How can we separate these two classes? Can we draw a line between these two? Guys, I'm asking you, can I linearly separate? Can I separate these two? How can you separate linearly? So, no. Why is it no? You can separate this, right? Can't I separate with a line like this? So if the point lies after here, that is considered as orange. If the point lies before this line, thus it is considered as apple. So can you separate the data points in this way or not? Not only in this way. There will be so many ways. You can separate like this. You can separate like this. You can separate in this way. You can separate in this way. You can separate in this way. There are so many ways with which where you can separate this. But the separation line should be the best fit separation line. The separation line should be best fit separation line. How can you consider this best is this is the separation is a best line? This is purely based on calculating the distance from the nearest point. Calculating the distance from the nearest point. So let's suppose I am considering this point as well as this point. So you can see this, right? There is some sort of line which is in between the point as well as the hyperplane which is considered. Here also a separation line between the green point as well as the separation line. So we are considering these points and calculating the equidistance of the points. Calculating the equidistance of the points. So you can consider these points as vectors. You consider these points are vectors. So the reason why it is called as support vector machine is the hyperplane or the best separation line is created with the help of some sort of support vectors. So these support vectors can be many. It's not like only one support vector. It can be many support vectors. One support vector, two, three, it could be anything. But the distance between the support vector and the margin line of one class to the other class should be equal. So here the distance from this point and this point and this should be equal. Then only you consider that as the best margin line. So the whole thing is considered as maximum margin. I already told you these 2 points are considered as support vectors. Support vectors. So here maximum margin hyperplane. This is negative hyperplane. This is positive hyperplane. So if suppose any point lies in this range, in this, then you consider that as orange. And of course, here also you can consider it as orange. Why you are considering these support vectors, I'll tell you now. All right. So this is a green apple and this is a orange, right? So there is the probability of apples looking like oranges and oranges looking like green apples. So let's see this. So here, can you see some apples are somewhat like orange color and all? Can you see that? So what happens then? What happens? So whatever the support vectors that we are considering are the apples which look similar to oranges. The support vectors or the apples which look similar to oranges. In the same way, here the support vector is an orange which look similar to a green apple. Which look similar to a green apple. Remaining all are correct apples and remaining all are correct oranges. So here we are considering the classes in such a way that even though an apple is looking like an orange, still it will predict it as an orange based on this hyperplane. Based on this hyperplane. So now apple which looks like orange will lie here, will lie over here. Yes or no? So whenever it is lying over here, it is in the negative margin. So that means it is considered as apple only. This is what SVM is. So can you see this? An apple which looks like an orange which looks like a green apple. So these two are can be considered as the similarities to the opposite class. So this is what the SVM is. So did you understand this? Any doubts? So in KNN, we will have some sort of problem. Okay, for suppose this is in what color? Orange color, and actually this is an apple. Okay, so this point is somewhat pointed over here. Now when you calculate the distance somewhat over here, let's suppose, okay, when you calculate the distance, it will be nearest to orange points, not to the apple points, right? So at that time, what happens? It will be misclassified as orange, right? Misclassified as orange. But actually, this is an apple. But whenever you have this SVM, the support vector machine kind of thing, then even though an apple is looking like an opposite class, it is correctly predicted as a apple. Did you understand this, guys? Guys, if you don't give any answer, I cannot understand whether you have understood or not. Did you understand this or not? Everyone. Now, I'll just, so you will get a better clarity when I plot it in the graphical representation. So let me just take a Word document. So, yeah. So let's suppose, let's take a data set which is color is green, and I consider this as green apple. Size is somewhat like 25 centimeters. 25 millimeters. Let's suppose output is apple. All right. Orange. It is also 25 millimeters. 25 millimeters. And this is orange. Now you have another one which is in green color. Okay. And this is like 10 millimeters. This is apple. You have red 25 mm. This is apple. Okay. You have green 20 mm. This is apple. Orange 25 mm or 15, let's suppose 15. Orange, green, 12 mm orange. So green oranges will also be there, right? Right, fine. So this is the data set that I have, let's suppose. Okay. Now what I do, I'll plot a graph. Okay. Fine. So here, let's suppose I plot a graph. Okay. Red, green, orange. 10, 15, 20, 25, 30. All right. So first one is green and 25 meters. I consider it as apple. Next, orange, 25 meters. I consider it as orange. Next, green, 10. I consider it as apple. Next, red, 25 meters. I consider it as apple. Next, green, 20 meters, 20 millimeters. I consider it as apple. Then orange, 15 millimeters. I consider it as orange. Green, 12 centimeters. I consider it as orange. Yes or no? So actually, these are some sort of correct looking apples, right? No, wait, is it some sort? Oh, yeah. Now let's suppose I have another color, some sort of orange color. 13 centimeters. I call it as apple. Okay. So now here what if an orange, 13 centimeters. Okay. So here these two are considered as oranges. But this one is like near to this one. But this is actually orange looking like apple. Right? Is this right? Green? Yes. So green, this one is an orange looking like an apple. This one is an apple looking like orange. Yes or no? So whenever a new data point is being replaced here, so it will first calculate the distances. Let's suppose this is the distances. Now this is actually an orange one. Okay. So based on this distance, here the majority values are lying. So at that time, what happens? This orange is misclassified as apple. At the same time, if suppose you put an other one which looks like something orange or so, apple or so, it misclassifies that as an orange. So that is replaced with SVM. So how is it replaced? With the help of a hyperplane between this one. So this is the support vector. So if you draw a hyperplane, the distance between this should be similar. So even though some other values which are similar, if even though the apple is similar to orange, it is correctly classified as apple only. This is because of the SVM. Here you will have some sort of hyperplanes. So because of this, the proper classification has been possible. So did you understand now? Did you understand now, guys, this? Or do you have any doubt? Did you understand this now? Yes? Good. So this is what all about SVM is. All right? Okay, fine. The data is like, fine. So with the help of SVM, we have created a hyperplane and we are able to separate these two lines with the help of a line. That's very good. Nice. But what if the data is in this way? Can you linearly separate it? Can you linearly separate it, guys? No. So what is the way you separate this? Yeah. So you can separate this with the help of a circle. So you cannot separate like this. Then what is the way? As these are not linearly separable, you cannot separate them. You can separate that in a circular way. So how can you separate this in a circular way? How can you separate this in a circular way? For suppose, if you see, I'll just put it over here. I'll just put it on the graph. Paint. How can I show you this? Okay, fine. So let's suppose, yeah. So this is the data, suppose. Okay. Okay. So I want to separate it. How can I separate it? I can separate it whenever I move the data to higher dimensions. So this is a two-dimensional data. Now what I do, I just create another dimension. I just create another dimension and I shift this black points downwards. I shift this black points or red points downwards. Okay. So here my black points have shifted downwards. My red points are shifted above. Right? Now I can happily separate this data with a hyperplane. Yes or no? So now whichever the data that comes below this are considered as black. Whichever the data that comes above is considered as white. Now here these are considered as the support vectors. All right. So whenever you want to separate any two-dimensional data which is not in a linearly separable mode, then what you have to do is you have to convert its dimensions. If it is one dimension, you have to convert that into a two dimension. If it is two dimension, then you have to convert that into a three dimension, so as to have some sort of separate line. So let's see what happens here. Now, let's suppose I take a single dimension one. So here I have all the points like this, red points and green points. Now I cannot linearly separate it. Yes or no? So what I do, I make use of some function f is equal to x minus y. It's a random function, guys. Some sort of mathematical functionalities I'm considering. So what, I am shifting all the values towards some side. After that, I am squaring it. So whenever I square it, these points move above. Yes, these points move above, right? So after moving above, then I can create a separable line. I can create a separable line. So did you see this? So if suppose the data is in one dimension or so, I can shift them to two dimensions and then I can draw a separable line. Yes or no? So that's what even here I did. So here also I have applied some sort of formulas so that all the black points came down and all the red points are lying in the same plane. Then I am drawing a separable plane. In the same way, for this data set also, the same thing is being happened. So I have used some sort of mapping function. So all the functions have been drawn, all the red points have come downwards, and all the green points have been created over here. Then I can create a linearly separable plane, right? So if suppose the data is two dimension, you can draw best fit separation line. If suppose two dimensions, then you can draw a hyperplane. Right? Did you understand this? How I am separating these values? How am I separating these values? Did you understand? I am writing some sort of function, guys. Did you understand, guys? Did you understand this or not? I'm doing nothing. I am just putting some sort of functions so that all the points will shift downwards or upwards, and then I am separating the line. But here for SVM, writing such kind of functions will be a very computational task. So that's the reason what I am using. I am using a kernel trick. So kernel trick is also a kind of formula based only. So based on this formula, I am shifting the values upside or downside. So this is the kernel trick. Let's see what does this kernel trick do. So here we have different kinds of functions which are used to separate the data. One is e power minus double mod of x bar minus li bar whole square by 2 sigma square. Another is we have sigmoid kernel, and other we have is polynomial kernel. So these are the different kinds of kernels that will be there for separating the data so that you can linearly separate the classes. So now here we will be looking at Gaussian RBF. So this is what is called as Gaussian RBF curve. So whenever you apply this functionality, all the data will be surrounding in this way. All the data will be shifted in a sigmoid form. In the by a Gaussian format. So all the red points will go upward and all the green points will be coming over here. Now what is this Li? Li is nothing but the landmark. So this tip is nothing but called as the landmark. So this is the 3D dimension, guys. So all the points are on a plane. On a plane, I am applying this Gaussian kernel. So this one is called as landmark. So the below one, this top one, if you scroll down, if you just draw a line, this is considered as a landmark. This is considered as a landmark. So can you see this? This is considered as a landmark. So whenever that value is near to 0, that means the point is far from the landmark. Far from the landmark. If suppose the point is, the k is 1, then that point is near to the landmark. So whenever you apply this function to all the values, this is considered as the landmark. So whenever the values are 1, if you substitute this formula, then this k value will be either 1 or 0. 1 means which are very near, 0 means which are very far. So based on these functions, these values are shifted upwards. These values are shifted upwards. So whenever these values are shifted upwards, then you can draw a circle in this way. So these are the near points, right? So near points are over here. Near points are over here, and far away points are out of it. Far away points are out of it. And this circle is also purely based on this sigma. Sigma is nothing but called as standard deviation. So I have already discussed about the standard deviation, right, in the last few classes. So you have to make this sigma in such a way that the circle is drawn properly. If suppose sigma is very high, then the separation will be wrong. So can you see green points are also considered as red points, because here also k value is becoming 1. If suppose sigma is less, then this is also getting misclassified. So this sigma should be properly selected so that it creates a particular round. So in order to separate these values, you are using a Gaussian kernel. So I'll just show you one video in YouTube. You will understand what's happening in that. All right, guys. Yeah, see this. So can you see this? So this is the plane. So what happened? You have applied a Gaussian curve. So what's happening? All the points are moving upwards, creating a circle. So if you see, a circle is created. Can you see this? A circle is created. So this is how this separation will take place. So basically that is in the 2D dimension. So whenever you showcase in the 2D dimension, it looks like a circle. Basically that is a hyperplane. So what happens now, based on that kernel, all the points are moved towards other side. So after that, you are applying some sort of function where you are drawing a circle based on k is equal to 0 and 1. So did you understand the GIF? Now did you understand what happens if the data is in this way? Did you understand, guys? Did you understand what's happening here? Yes? Yes. So this is what the Gaussian FB is. So you can see here again. So first the data is being moved upwards. After moving upwards, with the help of a landmark, you are calculating the values. So wherever the value is 0, till there a circle is drawn. Can you see this? So whenever you showcase it on a 2D plane, it is like a circle. So did you understand now? This is what Gaussian FB kernel used for classification. Understood, guys? So here the same phenomena happens. First, all the points move forward. So based on the landmark, it draws a circle. So did you understand this? Everyone, did you understand this, guys? Yes. So these are all about SVM. So let's take a break for 10 minutes. Then we will go into the practical implementation of SVM. All right, guys? If you have any doubts, you can ask me.